Hello, my name's Toria and I'd like to introduce my PhD project. Particle engineering approaches to control the interaction of medicinal aerosol with the lung environment upon inhalation. Aerosol drug delivery is widely used in the treatment of respiratory and systemic diseases and conditions, an example being asthma, which affects approximately 235 million people worldwide. When aerosol drug particles enter the respiratory system, they transition from ambient conditions to 37 degrees Celsius and 99 to 99.5% relative humidity. In such high humidities, aerosol particles can change drastically in their size, shape, and morphology due to dynamic processes known as dissolution, hygroscopic growth, and agglomeration, and these can be seen in Figure 1. These changes may then affect the deposition, bioavailability, and toxicity of the drug particles, and consequently have a significant impact on patient outcomes. As such, to fully understand and optimize drug delivery to the lungs, the physicochemical particle properties that influence the particle deposition, processes, and fates must be studied and their effect quantified. To study these properties, it is necessary to be able to produce nano and microscale monodisperse aerosol particles that have tunable characteristics. To this end, I'm going to develop a microcrystallizer system using a combination of microfluidic, anti-solvent crystallization, and spray drying techniques. These methods have been chosen due to the high degree of control they yield over the synthesized particle properties, their industrial scalability and cost effectiveness, and because they produce particles on the microscale without the need for high-energy milling processes. Once set up, I'll use the microcrystallizer system to produce particles of known chemical composition, and then systematically vary their physical and chemical properties, such as their size, shape, surface area, and degree of crystallinity. I will also be producing particles with different surface coatings that vary both in their thickness and their composition. Finally, I'm going to characterize the engineered particles using a range of techniques, which can be seen in the top right-hand corner of the poster, and examine how the chemical and physical particle properties affect the interaction of solid aerosols with water vapour in the conditions similar to that of the respiratory system. In doing so, I hope to help enhance the understanding of the fundamental underlying principles of aerosol dynamics in the respiratory system, and contribute to the potential for the optimization of aerosol drug delivery techniques in the future. Thank you very much for listening.